Okay, so the probability of one false positive is 0.004 times, so that's just one false positive, would be 0.004 times 0.996 to the 199th power, right? Because there's 199 people that actually got the correct test result, right? And only one of them got a wrong result. So I'd have to do this all the way up to the 200, false positives. Well, that seems like a lot of work.
It does.
Angie?
What does the corner say? Sorry.
No, it's okay, let me move it up. The corner says, so this is just like the probability. So the probability of a false positive, sorry, it looks kind of, is 0.004, which means them actually getting like a negative result when they really are negative is 1 minus that, so 0.996.
Oh, okay.
Okay? So I don't want to do this. Any thoughts on a different route we could take here? That like
So not
this,
just talk
this
to
kind
figure it
of
out?
jars your memory of maybe?
Oh, 90, is it the empirical rule?
No.
Oh, the complement. They cancel
The complement, right?
Oh.
What's the complement of at least one false positive? That means it's from one false positive all the way up to 200 false positives. What's the only other scenario that's not like taken into consideration here?
None false.
No false positives, right? So the complement of at least one is going to be none. Does that make sense? So this is something that happens often in problems. So the complement of at least one is going to be none. In many scenarios, this shows up a lot, okay? So, for example, on the AP exam, they might give you something where there's like 10 options, so that if you did it by hand, it wouldn't be the end of the world, but it's also going to take a lot of time that you don't necessarily have when you only have 15 minutes for each free response question. So it's a really good thing to remember that if you're trying to find the probability of at least one thing happening, the complement of that is none, right? Does that make sense? Because again, like over here, if we just think about the number of false positives that can happen when you test 200 people. I could get 0 false positives, 1 false positive, 2 false positive, 3, 4, all the way up to 200. So if we're looking at the probability of at least one, we're saying all of this. So the complement is just what's not in this box that I have. Does that make sense? Okay. So what we're going to do is the probability of at least one false positive is going to be 1 minus the probability of no false positives. It's supposed to be a positive. Let's. Okay. So what does that mean? What it means is all 200 are negative, right? Is that what that means? So in terms of our probabilities that we've got, what was the probability of getting a true negative test result back? 0.996. How many times?
200.
200 times, right? All 200 of them. So again, the scenario is everybody is HIV negative. We picked 200 people that really and truly are HIV negative. What's the probability that at least one of them gets a false positive? So the complement is there's no false positive, everybody gets the true negative result. okay? So that ends up being 1 minus 0.4486, so 0.5514.
Not kind of high.
Yeah,
Half.
yeah, more than half, right? So, like Kat said, there is more than a 50% chance that at least one of the 200 people tested will test positive for HIV, even though nobody really has it.
So does each person being picked have a 50% chance?
No.
Okay.
It just means of these 200 people, they got a 50-50 shot that at least one false negative is going to show up.
Okay.
That's it. So I might do 200 people today, no false negatives. False positives. I might do 200 people tomorrow, got a false positive.
Okay.
Okay. So it's not that like each person has a 50% chance, each person has a 0.004
I see.
probability that they're going to get a false positive. Okay. So again, anytime you get a medical diagnosis, right, you always get a second opinion. You don't just like, some doctor tells you you have cancer, you don't just start chemo tomorrow, right? You go see somebody else, you make sure that you have the right diagnosis, and then,
Do you think they warn the people? Like when they're getting the HIV
I would think so.
shot?
I would certainly hope so, that they would say, hey, you know what, there is a 0.004 chance that this is a false positive, we're gonna do it again. That, yeah, I would assume they would do that, okay? But I don't know, Okay, so just a little guy here to just remind you of a couple of things. So the multiplication rule, the probability of A and B, holds if A and B are independent, but not otherwise. So, like for example, let's say we've got, what's the probability that I,
Got a parking ticket.
I roll a 5 and then a 6, right? So I have a die, I roll a 5 once, I pick up that die, I roll a 6. Does my first roll have any at all impact on my second roll? No. So I can just say, hey, what's the probability of rolling a 5? What's the probability of rolling a 6? And multiply them together, right? So 1 out of 6 times 1 out of 6, so 1 out of 36. Make sense?
Yep.
Okay, but let's say I'm doing something with cards. Okay, let's say I want to know what's the probability that I
An ace,
deal, sure, an ace,
and
and
then
then
another ace.
great, then a second ace. Okay, so we're dealing them out to people. We're like, I'm giving them to somebody. So once I'm dealing things out, right, they're no longer in my deck. So it doesn't equal the probability of an ace times a probability of an ace. Right? It's not, how many aces are there? 4?
Mm-hmm.
It's not 4 out of 52 times 4 out of 52.
Would it be
Instead, it would be probability of the ace times, I don't even know how you would write that.
Yeah.
Like, you would
Wouldn't it
just,
just be 4 out of 52 times?
3 out of 51,
51.
right? So it's not, you can still do it. You still multiply, but it's not like the original. Okay, so instead, you would just have to take into consideration that you dealt an ace. So 4 out of 52 times 3 out of 51.
So you still could.
So you can still multiply, you can still do it, but it's not like the original probability. Okay, does that make sense? Margo?
I have kind of a different question
Okay.
going off this. So what if it was like deal an ace and then deal a different number? Would it be 4 out of 52 times 4 out of 50 or
51. Because that ace is still in somebody else's hand that I gave to them,
Okay.
right? Does that make sense?
Yeah.
So yeah, so if it was a probability of an ace and a probability of a 7,
Okay.
it'd be 4 out of 52 because there's 4 aces out of the 52 cards, and then there's 4 sevens, but now it's out of 51 cards because that ace is no longer in my deck that I've got. Okay.
Thank you.
And then so the addition rule, the probability of A or B, equaling the probability of A plus the probability of B, holds if A and B are mutually exclusive but not otherwise. But with that one, remember, if they're not mutually exclusive, then you just subtract the overlap. Okay? So you just have to be really clear in your head about what these words mean and what formulas apply to what, and you can still find the probability of A and B, the probability of A or B. You just have to like make sure you have the situation straight in your head. So just be careful. Don't just like blindly start throwing around formulas. Okay, like really think about it before you start using them. Okay. So this is an example. This is not anything for us to like, there's nothing for us to do with this. We're just gonna read this little situation. So Hacienda Heights and La Puente are 2 neighboring suburbs in the LA area. I have no idea where either of them are. I'm sorry, I don't know anything about
I know La
anything.
Puentes.
Great. Must be by Hacienda Heights, right? Okay.
There's a card.
According to the local newspaper, there's a 50% chance of rain tomorrow in Hacienda Heights and a 50% chance of rain in La Puente.
Oh.
Does that mean that there's a 0.5 times 0.5 or 0.25 probability that it will rain in both cities tomorrow? No, it's not appropriate to multiply these two probabilities because the events aren't independent. If it's raining in La Puente,
It's most likely gonna rain in
and
Hacienda
Hacienda Heights is pretty darn close, right? They're not independent of one another. If it's raining in La Puente, then I know there's a pretty good chance that it's raining in Hacienda Heights. Okay? Suppose that there was also a 50% chance of rain in New York tomorrow. To find the probability that will rain in Hacienda Heights and in New York, then it's appropriate to multiply the probabilities because knowing if it's raining in New York, does that tell you anything about rain in LA or the LA area? No, okay? So in that case, we could multiply them together. So yeah, you just have to make sure you've thought about whether or not the events are independent. And honestly, if it's something that's, like sometimes you might be asked to like explain whether or not you think events are independent, and in that case, as long as you provide reasonable like support for your position, then you're fine. Okay? If it's something like that baseball one with the perfect innings and whether or not, one inning is independent of another inning, then they would probably tell you whether or not it's independent because otherwise it would be hard to know. Okay. And also with that one, if they didn't tell you it was independent, like there's no way to know, okay, I pitched one perfect inning,
How that affects me.
I have no idea how it's gonna affect the next one. So in that case, if it's not independent, then I have no way to do the problem otherwise. So you guys have to think about that.
Oh, you have like a minute left.
Oh,
40
okay.
seconds.
What?
40 seconds.
Okay. All right, so the last little thing. So first let's do this.